Okay, so good morning, everybody. It was a long weekend for all of us, so I hope everyone has enjoyed the same and you have refreshed yourself.
Yeah, good morning.
Okay, so the agenda for today's session is on the screen. As discussed, we'll be starting with the pull request at the beginning. We'll understand what exactly the purpose of pull request is, what are the benefits, the best practices to be followed for creating and reviewing the pull requests, and then practically how to create and review the pull requests in the Git repository. Then we'll move on to discuss about how to implement Git workflow in a Git repository, followed by the GitHub Actions, where we'll be using the GitHub Actions to integrate the continuous integration and continuous delivery for our applications. So the introduction to CI/CD itself, the benefit of it, different stages that we need to go through the CI/CD pipeline or to configure the CI/CD pipeline, then understanding of the GitHub Actions and its capability, followed by the practical on how to create the simple CI/CD pipeline using the GitHub Actions. Okay, so let's begin with the first part, that is pull request. So just to quickly summarize what pull request is, if anybody remembers, please share.
Before moving the original changes to the master branch, whatever they are in the master previously, that we need to pull
Yeah.
uh, and the whole changes again we can push to the master main branch.
Hmm. So what is the role of pull request in this?
It will bring the existing uh, application logic to our local branch, and from there we can push it back to the main
Okay.
branch.
Yeah. So one important activity which we do with pull request is basically as a team, we look at the work which has been done by the different team members and we get it reviewed. We see or we try to see if there is any issue which can surface out of this code, or if this code is acceptable as per the requirement, it aligns with the requirement or not. It gives us the same outcome which we expected from this implementation or not. And after thorough review, we allow this code to be pushed into the CI/CD pipeline so that it can be then finally integrated with your production code. Understand? So that is the purpose of the pull request, right?
Okay.
Okay. So pull request, there was another terminology which I said is used usually in some of the version control systems. Particularly if I talk about GitLab, there we don't have pull request, we call it as merge request. It's like I have done something as a team member and I am asking my team members to allow me merging that work into the main branch or master branch, which by default means that the team has to review the same, right?
Okay.
Okay. So let's understand what all different purposes are there with respect to the pull request, what all things we target, which starts with the very first important thing, that is review or code review to be precise. And probably we all know what is code review and what is its purpose. I write my code under my allocated task, I probably commit that code also into my feature branch or maybe the bug fixing branch, right? And then I want this code to be integrated finally into my master branch or main branch. Before which I want my other team members to review the same code. Team members include my colleagues, in some cases, my juniors also, and in most of the cases, basically the leads, team leads, module leads, etc., who will examine the code, suggest any improvements if required. If all good, it will be just accepted. Otherwise, they will provide their suggestions and they will identify the potential issues also before the code is actually merged in the main or master branch, right? So this is one of the most important purpose of the pull request. Understand? The next purpose why we do this code review itself is something about QA, quality assurance. Because by having a thorough code review, basically the pull requests help us ensure the code quality and maintain the coding standards also. So your code might be good, but there might be some standards which have been set by your team. The purpose of code review is also to ensure that whether all the code standards are being followed or not, appropriate comments have been put into your code at the right places or not, right? So this is also taken care of during the code review process or pull request itself. So by reviewing and discussing the code changes, ultimately the teams can catch the bugs, improve the code readability, and maintain the consistent code practices easily, right? So that's what QA takes care of. Understood?
Yes.
Next is collab or collaboration.
Saket, I don't
Yes.
understand what
Yeah.
QA will do here.
See, quality assurance, when we talk about what is exactly the quality assurance? Is it only about the finished product? In a sense, yes, also, but ultimately from where that originates. If your code is a quality code, by default, your final outcome will be quality outcome. Agreed or not?
Yes.
Just take an example. I'm looking to build a new car. If I don't perform this QA practice on individual components before it is integrated into the car, will I be able to achieve the quality result at the end?
No.
So whenever individual component comes in, whether it is built by my team or built by my supplier, before accepting it into my assembly, if I perform a quality check on it, it is going to help me in long run. Am I right?
Yes.
So quality check includes multiple things: the build quality, the material used, then the compatibility with my car, what I'm building, right? The size and the other specifications, physical specifications, everything I need to see whether they are as per the required standards or not. And then probably I discuss that with my team if my team has built that, or with the supplier team if supplier has built that for me. Once I see that yes, I have received the quality component, probably then I can integrate it with my actual vehicle as a product. Yes.
Yes, Saket, but here we are talking about pull request, so I'm not understanding
Yes,
the
so coming
context.
to that also, coming to that also. So I hope this is something which is clear, right?
Yes,
Doing the discussions, doing the quality checks at different stages, right? Now, why we are creating the pull request, it actually originates from here only. Pull request, one of the most important portion of that is code review. We create the pull request not only to get my work merged with the main branch or the master branch, but also to ensure that my team goes through whatever the work I have done before accepting it into the main branch. Because when I do something, I have something in my mind. I have my own perspective while writing the code or while deciding that, okay, this way I will code, right? So when I do my own quality check, my own test on it, probably the mindset of mine is applicable there as well. I cannot see the independent view of what I have done because I'll be biased towards my own decisions, right? That's where the other team members can help. I can ask them, please find out if anything is missing. Please find out if any standard is not being followed or some improvisation is required. Or maybe the code I've written, somebody has written that kind of code or that kind, someone has done that kind of work in the past and probably have faced issues with the procedure that I have followed. So they can come up with their suggestions as well. Understand? And if this is done at each and every component level, probably there will be high chances of having the quality product at the end. Yes or no?
yes,
Right? So that's where the quality assurance comes in. Do it at the granular level so that the end result will be better. Make sense? As I said, by reviewing the code, by discussing the code changes, whatever you have done, you and your team will be able to catch the bugs, the issues easily and early. Also, the target will be to improve the readability of the code by ensuring right comments are there in right place. And ultimately, allow you and your team to maintain the consistent code practices. Yes or no?
yes.
So that's QA. I hope it is clear now.
So you mean to say that, for example, I have written a code and I raised a, PR. So before it's merged or it is reviewed, so I have a check with the QA team.
Not QA team, your own team, where some members from the QA also might be there as a part of your team. And these days with DevOps coming in, actually we don't have separate QA team, right?
Yes.
It's the entire team which works as a whole, correct? Every
Yeah.
developer is a QA engineer also. Yes or no?
Yes.
Yeah, the high level testing unit, the integration testing and all. For that, we might have qualified QA engineers, but at more granular level, whether the code should be okay to be merged with the main branch or not, this is something your team itself can decide. If someone senior is there in the team, they are senior because they have got some experience, right? So they can suggest that, okay, you have done this, okay, this is working also, but probably the way you have implemented something might result in some issues in the future. So adjust your code this way. They can give you suggestions, right?
Yes.
That's what the whole idea behind this activity is. Clear?
Yeah. I understood that it's involving the QA team and doing some kind of.
Right, right. For crucial things where QA team needs to be there, they can be there as the part of the PR activity also. Understand?
Yes. Thank you.
Okay. Next is collaboration. Why this point comes in? Because ultimately we are doing the entire activity as a team, isn't it? So in a way, the pull requests are encouraging the collaboration among the team members. They are actually providing a kind of a forum where the team members can discuss, can share knowledge, can provide the independent feedback about the work done by other team members. And ultimately, the purpose of this activity is where developers can work together as a team to find solutions to the problems and make corrective and collective decisions. If all agree, it's agreed. Yes or no?
Yes.
So that if something goes bad also, the blame doesn't come on one single member, which is not actually good for the individual and for the company also in the long run. Am I right?
Yes.
Okay. Next is in this process itself, we also target something called as conflicts. So basically, we work towards resolving the conflicts. So I put it this way, conflict resolution. Why this is important is because when multiple developers and team members are working on the same code base, the pull requests are there, which can help you detect and resolve the merge conflicts pretty early in the entire development process. Instead of having the merge conflict or any kind of code conflict later on when we are doing the integration of the entire product, it will be very difficult to decide on what to accept, what to reject, and again make the changes accordingly in the subsequent code, right? That's why conflict resolution at the early place is important. It actually reduces the likelihood of introducing the errors into your code base. There is some module on which I have done something, and at the same time, you have also done something. Now, 60% of my work is correct. Maybe 70% of your work is correct. And that 60% of mine and 70% of yours need to be taken as it is. Whereas 40% of mine and 30% of yours probably is not good enough. So that's what you can actually do with the help of the conflict resolution. As a team, you will be discussing on that and deciding what code to be taken into consideration and what code to be rejected, what implementation needs to be rejected. Understand? Yes?
Yes.
Yes. So basically, very simple example from our day-to-day life is there, right? You and your sibling, probably while being kids, we it's a human tendency. Basically, I'm not blaming anyone, but many a times the conflict happens between the siblings, right? Now, what is the effective way of resolving that conflict? Parents or someone elder basically sit in between. They try to talk to each of the sibling and listen to their part, and probably they provide a solution where some of the demands of one of the person, one of the sibling, and some of the demands of another sibling might be taken into consideration, and some midway is found, and the conflict is resolved. So the activity is totally driven on this emotion only, right? The whole purpose is to be on the same page for each and every team member. Instead of one saying, okay, go this way. The other one saying, go that way. Find out a midway in terms of solution, right? What is good? Finding the midway or just following some one team member?
Finding the midway.
Because that probably will be the best solution, right? Which takes care of the issues raised by each of the team member. Yes or no?
Yes.
And then the last one is documentation. We use pull requests to ensure that documentation is also being made or prepared for all the code changes, so that later on, whenever we need to rework on that code, any team member can understand what has been done till now. Because this documentation includes the information like the scope of changes, the context of the changes, the documentation on the discussion happened during the PR process also, which makes it easier for all the team members to understand the overall idea behind the specific change. Got my point?
Yes.
Let's talk about some of the benefits of PR. This was purposes of the PR, right? Now let's talk about the benefits. Some of the benefits should be visible from this only. First one I'll put as code quality assurance. Because we are doing all the review activity, the discussions and everything to make sure my code is good. My quality of the code is good, right? So the pull request eventually improve the code quality by making sure that the changes are discussed between the team members, something what we also call as peer review, right? So this helps in various aspects like maybe logical issues, syntax errors also, and any other problem which probably can impact the code base in future, right? Next, with the collaborative environment, we also discussed about people can share their knowledge. Someone with more experience can share their experience with little junior people, so that junior people can also learn the things pretty quickly and can become the decision makers pretty early. So it's good for the growth of the individual, plus that means it will be good for the growth of team and the entire organization. Yes or no?
Yes.
Yes.
Each team member might be having some very specific skill. I mean, someone might be good at something, some other might be good at something else. So knowledge sharing basically will help all of us to understand the things pretty easily and pretty quickly. I don't need to spend time on each and everything to be learned on myself, right? This is equally applicable when you are working on some new stuff, new type of project from new business domain, or maybe some new technology being adopted. Everyone need not learn everything at the very beginning. Each team member can target specific areas, can study, can work on it, and then during the pull request meetings, people can discuss among themselves what they have learned about that uh, targeted area. So in a way, in a short span of time, everyone becomes aware of most of the crucial things, whether it is with respect to the business domain or with respect to the technology. Yes or no?
Yes.
Then from collaboration, there is another benefit which comes out: enhanced communication. Because communication can be done on Teams, communication can be done on chats, can be done on emails, but that is not very effective. When we sit as a team and discuss multiple things, we can put forward our open ideas, right? Yes, because this activity will be providing a more structured channel for discussing any changes, making any suggestions, and addressing or targeting any concerns which might be there in someone's mind. Okay, because many people are there who probably are more comfortable in written communication. Many other people are there who are more comfortable in verbal communication. So this peer activity can bridge that gap. Yes or no?
Yes.
Next is risk mitigation.
Saket,
Yes.
so only few of the members will be reviewing the code, right?
See, when we talk about the teams in agile environment, the team size will not be very big. Correct? We have smaller teams. So the entire team working on that specific module will be involved. Not only few team members, but everyone who is working on that module probably will be involved. Yes.
Yes.
Even if someone has not worked directly on the piece of code, they can still have some ideas, right? With their past experiences. So they can be involved into the team meeting for the pull request or review process. Yes.
Yes.
Okay. So risk mitigation, what is it? PR helps in reducing the risk of any introduction of the regression, means making changes, breaking some other piece of code in my implementation. That's what we call as regression. Also, PR helps reduce the risk of critical issues being introduced into the code base, because the entire review process helps you identify and rectify also the potential problems as early as possible. Early detection of the problem is always helpful instead of failing after doing everything, completing everything. Yes or no?
Yes.
Yes.
Next is workflow flexibility. As we discussed earlier in the previous session, that we have multiple different types of workflows which can be adopted, right? So you have the flexibility. As a team, you have the flexibility to implement the workflows into your pull request. Like maybe you can enforce some rules like requiring code reviews or passing the unit test before merging, and ensure that only the high quality code is integrated. So before the PR, you can make a mandate, you can make a rule that all the unit test cases must be returning the successful execution of the test cases, so that the time spent in code review can be reduced also. Probably in that case, the logical uh, details need not be spent too much time for the review. Syntax errors might be already taken care of. So that will help reduce the time required for the code review. Yes or no?
Yes.
Next is version control. Pretty important thing, because with version control, the teams are enabled to track the changes, what changes have been made, who made those changes, when those changes were made. Not only something about the code, but the history of the discussions, history of the PR outcomes also can be maintained. And in a way, we can actually maintain an audit trail of all the code modifications. Understand?
Yes.
Next is contribution tracking. So this is actually an extension of version control only, which focuses mainly on maintaining the clear record of who all have contributed to a project, what changes they have made, and when. This is very, very valuable information for acknowledging the contributors and tracking project progress. So project is benefiting at the same time who is contributing well, and someone who is performing at the top level can be tracked as well. So if the project goes successful, the credit can be given to the right people, right? So personal growth is also something which benefits with it. Yes or no? Next is safe code integration. As the changes are reviewed and tested before being merged into the main branch, the process of PR reduces the risk of breaking the code base at any level. So that's what safe code integration is. And then another benefit is branch management. As the PR by default facilitate the branch management, as they help you decide when to create, merge, or delete the branches, keeping your repository organized and clutter free at any point in time. Yes or no?
Yes.
Right? So what we learned in these two things, in summary, or in summarized manner, if we want to put it, pull requests are a vital component in modern software development workflows, right? They help us ensure the code quality, better collaboration, along with providing a structured process for the code review and integration. Following the pull request process or workflows ultimately can lead to more efficient development practices and better quality code base, right?
Yes.
Okay. So let's talk about the best practices for creating and reviewing the pull request. Because if pull request itself is not following any best practice, the whole purpose of pull request or code reviews will be lost, as it is one of the very important step, right, in the development workflow. So let's talk about the best practices for creating and working with the pull request. First is create a descriptive title. You should always look forward to provide as clear and concise title that can summarize the entire purpose of the PR. You should avoid the vague or generic titles at all times because they might confuse the team members, right? Make it as descriptive as possible, but at the same time, not too long, not too big. Okay. Clear?
Yes.
Next is along with the title to elaborate it further. You should write an detailed informative, or we can just put it informative description. So by some reason, for some reason, if some team member or any stakeholder is not able to understand the purpose of the pull request, can just go through the description to see complete detailed motive behind the specific pull request, right? The description should explain why the changes are necessary and whatever the changes we are making, how they are addressing the issue or the feature. Got it?
Yes.
Next is always reference relevant issues. Practically, if the PR is relating to an existing issue or a feature request, try to mention it. In fact, always mention it in the description, for which you can take help from the repositories issue referencing syntax also. Like fix number n, where n can be any number, right? Feature, number, and whatever number. Closure, number, and whatever number. Understood? Somewhere you mentioned that in the description. Okay? Because some work might be related to provide a solution to some bigger issue or some bigger feature request. So always try to reference that so that person can understand, okay, this is probably in addition to or in extension to what has been done over there. Okay.
Saket, so
Yeah.
like the kind of known issues the team already might have identified and they
Yeah.
kept.
So correct. So there might be 2 or 3 things which come out of that issue, and probably one issue is in itself a separate solution, but is also crucial for providing a solution to another issue. So here I'm talking about the dependent issues or dependent feature requests. Okay.
Okay.
So instead of saying dependent, we call it as related. Because sometimes my issue might be dependent on another. Sometimes it could be other way around. Another one is dependent on my stuff. Correct? Sometimes this dependency might be indirect as well. So that's why better term is related issues. Reference, relevant and related issues. Here,
Yes.
next is keep the PRs always focused. Any PR that you create must address a single issue or feature. If you create a PR which addresses more than one issue or the feature, it will confuse and the purpose will be lost. Especially when the changes are unrelated in a single PR. They will be very difficult to get reviewed and also very difficult to be managed. So if you keep it very focused, related to or focusing on single issue or the feature improvement, you will be able to make the reviews more understandable, more manageable. Got my point?
Yes.
Next is add appropriate labels. Labels, basically extra identification, some additional context, right? Which allow you to categorize the PRs also. Like if you're talking about the bug, make use of the term bug somewhere in the title and the description. If it is a feature improvement or feature enhancement, make use of the term enhancement. If something is about the documentation, make use of the term documentation so that your entire PR activity is readable and understandable easily. Got my point?
Yes.
Next is include testing and documentation. You just need to ensure that your code changes are including the appropriate tests and the documentation updates wherever and however applicable. Test coverage and the documentations are quite essential for ensuring the code quality. We have discussed that in the past. Yes or no?
Yes.
Another simple but important requirement is to avoid large changes in a single PR. Because if you make two big changes in the single PR, your focus will be lost, which will probably responsible be responsible for introducing the bugs, right? If you are breaking your work, your task into smaller incremental PRs, you will be able to easily review and merge the same. Yes or no? And time required for the PR activity also will reduce. Yes or no?
Yes.
Next best practice is to keep your coding style consistent. There should be some standard where each and every team member has agreed upon. So if all the team members are following the same project coding standards and the style guidelines, the inconsistencies in the code style will be reduced because they can be distracting and lead to multiple unnecessary code review comments, right? Which will be wastage of time and efforts. Yes.
Yes.
Then another simple requirement but important. Test all of your work locally before you actually create a pull request. I don't think this requires too much of discussion or explanation. So whenever we write code, we run the test cases. Before test cases, we do our own review as an individual. Then we run the test cases. One more review on the results of the test cases. And then probably we commit and create a pull request. So that very basic level issues can be identified early at our own level. And with this, we can prevent these issues from being identified during the PR activity, because that will be actually a negative impact on the individual's performance. Yes or no?
Yes.
And then last is request reviews. Assign one or more reviewers to your PR. I always go with more number of PRs or reviewers because multiple people can provide different viewpoints. Their feedback can help me improvise my work and also expedite or fasten up the entire review process. Got my point? Yes.
Yes.
Now, this was basically something about the best practices to be followed for creating the pull request. Now, suppose we have created the pull request already. Don't you think when someone is reviewing the pull request, there should be some best practices for the reviewer also? So here
Yes.
goes the list of best practices to be followed by the reviewer, which starts with understand the context as the reviewer. So practically here, what we mean by this is before reviewing any PR, take your own time to understand the overall context, which includes or which should include the issue being addressed and the goals behind the changes. Because if this context is not known or if you're not aware of it, you will not be able to conduct the correct PR in the correct way. Understood?
Yes.
Next is very important one. Review the code thoroughly. You should not just overlook the code. It should be a thorough review. If you make your assumptions that, okay, this person has done this, so this will be good only, that's a wrong thing. Because even the best of the developers can also make mistakes. Yes or no? So if you overlook, probably you will lay the foundation for the issues, bugs later on, and which will be hard to find out and fix at a later stage. So you should always examine and review the code very carefully in detailed manner. Look for all the potential issues, bugs, code style violations, or coding standard violations, and even the security concerns. Got my point? Don't leave anything unturned. You get my point? Yes or no?
Yes.
Next, as a reviewer, you should always provide honest, constructive, and detailed feedback. Just because my team member is my friend also, I'll not put any negative comments. This should be avoided. Okay, give the honest feedback, which is good for the person creating the PR also. Because the same kind of mistakes will not be repeated in future, right? The person will learn something out of it. And along with the feedback, if you know what is wrong and what is the solution for it, provide information regarding that also, because we discussed we are looking to use this PR activity for improvising the collaboration, for improvising the knowledge sharing. Yes or no?
Yes.
Your comment should not be always negative or random. Be very, very specific. and give actionable feedback. Means based on the feedback, the person can actually do something, suggest the improvements, alternative approaches, etc., whenever and wherever necessary. Clear? Yes.
Yes.
Next is focus on code quality. So with this, you have, as a reviewer, you have to ensure that the code is following all the coding standards, best practices, and is maintaining the code quality as per what has been decided during the team meeting before the development work started. Also, pay attention to the readability and maintainability of the code. Got my point?
Yes.
Next is test the changes as a reviewer also to see if any negative impact of the changes is there. And you should do this locally. So entire idea is to get the verification done for the changes that are suggested so that you can see if they are working as expected and are not introducing any regressions or diverse effects on the other modules and other piece of code. Got it? And as a part of this, you should check for edge cases also. Known term, right? While unit testing, we discussed about edge cases, the boundaries, extremes, right?
Okay.
Because that's where most of the time the issues are. Issues are present. Also, as a reviewer, you should not be just going with the negative mindset. You have to respect the author's perspective also. I use the term author. Any idea why I use this term? Because the content being reviewed may not be always code. It might be some comment. It may be some documentation also, right?
Yes.
So a generic term author has been used for that reason. Always acknowledge positive contributions. You have to recognize and acknowledge the positive aspects of the code. Like if you see the coding standards being well maintained, all the code is well documented, the tests conducted are pretty comprehensive, coverage report is pretty good, and the algorithms are also highly efficient, highly optimized. So acknowledge it. Usually for continuous positive contributions or positive acknowledgements, the team member can be rewarded by the organization or the project team as well, which will be good for his personal growth. Yes or no? Yes or no?
Yes.
Because always negative comments being highlighted and positive things being ignored will create negative mindset in the team member, which will affect the performance. Initially, this negative impact will be on the personal performance, which will reflect into the team and then to the organization. Correct? So say good when it is good, along with when you are saying bad for bad things. Yes or no?
Yes.
Yes.
Try to use code review tools wherever possible because they will help you do the code review more accurately. Yes,
Yes.
most of the version control systems probably provide some tools integrated within them. Try to use them. Okay. Then code review should be on time as well. Delays means it's a loss. So be timely and responsive. Always review the PRs within time. Delayed reviews can slow down the entire development progress, which might become bottlenecks at the later half. Yes or no? Developers will simply say, okay, I raise the PR, but the reviewer is not finding the time to get the review done. So how do I move ahead? So that's not good for anyone. Yes,
Yes.
as the timely work is important for a developer, the timely review is also important for the reviewer. Okay. Next is always communicate clearly. You should be always clear in your words that you are using within your feedbacks and concerns. Also be open to the discussions with the PR author because sometimes he might get the negative comments despite everything being good. Probably the reviewer didn't understand the mindset of the author before commenting. So have a detailed discussion and clear the doubt before you decide on whether to put the negative comment or positive comment so that you can avoid the misunderstandings between the two people, the author and the reviewer, right? Plus, these misunderstandings can be coming in because of wrong understanding of the context or wrong intention behind the context as well, right? Your intent might be something good, but some author, some person who has done the code probably might understand it in a different way, take it in a different way. So be very, very clear. Provide your context. Explain the reason why negative comment is there, why positive comment is there. Yes. And then the last one is approve and merge. As a reviewer, if you are satisfied with the changes and the changes are meeting the project's standards, approve the PR for merging. because after the approval only the author will be able to merge the changes in the main branch. Understood?
Yes.
At the end, I'll say by following these best practices for creating and reviewing the pull request, you can actually enhance the efficiency of your development process, maintain code quality, and promote the collaborative and constructive atmosphere within the team. Yes or no?
Yes.
Any questions so far? Okay, so time for the break. We'll resume the session at 11:10, where we'll practically understand how to create the pull request and then how to conduct the review. Got it?
Yep. Yes.
So I'll be back at 11:10. Hey guys, I'm back. Shall we proceed?
Yes.
Okay. So here we'll take a completely new project. Or maybe if you remember, we created this one for using the Git entirely from within Visual Studio. I created a web API project within which I have the default controller weather forecast. Then I created a model department and then employee class also I created there. Some changes I'm going to make over here. Like I'm removing employee, going back to department. I'll just add one more property over here. This is in line with the web APIs that we built during our web API session. Let's say here I have it as location. I put some .NET Core integration, .NET Entity Framework Core integration. So for that, here I say using system.component model dot data annotations. Data annotations dot schema. I put some annotations over here. So here goes my table attribute. Using table attribute, I give the mapping of this class with the database table departments. I want department number to be key. I want department number to be manually entered one. So I use database generated attribute with database generated option set to none. Regular stuff, right? Department name, I make it required. And not only required, but a minimum of 3 characters and maximum of 50 characters I want to have. So here goes string length attribute, which allows me to set the same requirement. And location, max length, 50. I'm sorry. Okay. I also have the data context class created over here. So here I say app db context is the name for which I need to have the framework, entity framework, NuGet packages to be added. Dependencies, manage NuGet packages. I go for browse and let's search for entity framework core. So Microsoft.entity framework core version 5.0.17 is what we used. Install, okay, accept. I'm going a little quickly because we have done this in the past. Along with this entity framework core, I need entity framework core.design, same version 5.0.17. Okay, I accept. Then I need entity framework core.tools, same version 5.0.17. Install, okay, accept. And then I say SQL Server package is also needed. Entity framework core.sql server version 5.0.17. Install. OK. Accept. 4 packages required are added. Close this tab. Then I go to app settings.json, where I create a section connection strings. Here goes the key SQL con. And here goes the value as server equals to within parenthesis local DB double backslash MS SQL local DB database equals to, let's say, Quinnox DB 2 trusted underscore connection equals true, and then multiple active result sets equals to true. Save, close. Let's code this appdb context using Microsoft.Entity Framework Core. That gives me DB context class as the base class. Have a property of type DB set of type department. By the name departments, and then followed by a constructor that takes in a single parameter of type DB context options chain to the base class constructor, to which I just pass options. Right. Then we go to startup.cs. Here we import a couple of namespaces, starting with Microsoft.Entity Framework Core.
Actually, Saket, to raise a pull request, we are making these changes.
Sorry?
To create a pull request, we are creating these files.
Yes, correct. So there must be something substantial to review, right?
Yeah.
So that's why I'm making the changes. So I'll not be going ahead with the API. Whatever implementation we have done so far for entity framework integration, that's what we want to review. Okay. So one last thing, which integrates entity framework here, services.add DB context. DB context. That's my own class. Options goes in. Options dot use SQL Server. Configuration dot get connection string by the name SQL con. Save. Build it to see any syntax error if there, it succeeds. Correct? And here as a developer, I now want to proceed with some Git options. So I go to Solution Explorer, right click on the web application, Git, and there I say commit or stash. Here I put my comment.
Actually, Saket, we need
Yeah.
to stage and commit. So that's what the problem previously we had.
Hmm. No,
Uh,
that was a different thing. That was a different error. Basically, that was because of some mismatch in the command line and the Visual Studio configuration. So here we won't have any issue as such.
okay.
Okay. So added EF core integration code is my comment. I'll say commit all. I'm doing this in main branch, but ideally you should be doing in a separate branch, right? The feature improvement or uh, the bug fixing branch. Okay. And then I want to create a push request first of all. So this project is already connected with the uh, GitHub repository, correct? In the last session, we did that already. So I just need to say push. And here I can say added EF core integration. Okay. Actually, it is pushed.
Yeah,
Yeah.
you have committed already, so you need to push.
Yeah, that's what I'm trying basically.
Yeah, that is the push.
Yeah. So, okay. So it automatically took the push. And here now we are getting create a pull request, right? So here we go ahead and use this option, create pull request. Okay, my mistake. I should have done this change in a separate branch. So sorry, so we'll just initiate it again. Let's close this and make further changes. Let's add an API here. So right click, add.
No, actually, you need to create a branch and do this.
Yeah, so we'll do that. Okay, so this actually can be done before creating the controller or after creating the controller. I just need to select the branch where I want to commit. So this can be done before or after. There is no problem with that. Okay. So let's do it this way. If you are comfortable with this, that's fine. New branch, feature improvement for adding departments controller. Okay. Spaces will be replaced with hyphens automatically based on main. I want this to be created and I want to check that out as well. So create. Then I add the controller here. controllers, add controller, API, API controller with actions using entity framework, add model, department, DB context, app DB context. I want to name this as departments API controller, add first of all, I'll build it. And let's assume that we have tested this as well. I just want to get this committed. Did I click? Why I'm not able to see the whole project? Yeah. Okay, so here I say right click the project and then get, then commit or stash. So here I had the chance of creating a new branch whenever I say commit, right? So I can add the controller before creating the branch as well. There is no problem with that. Here I'll say added departments API controller. Okay. And in this branch, I want to commit. So this is local. Then we need to go ahead and say push. It says initiating push. It has pushed. The branch also has been pushed, which we can actually check on the browser. Just need to refresh this view. So here we have the branches, and this is the active branch as well. I can create the pull request from the portal itself, or else I can just use this tool to create a pull request as well. Here also we have the pull request option, right? Pull. Let's say create pull request. It opens in a different browser window. It automatically detects what change has been there. So it took added departments API controller automatically, and the comparison between main and the feature branches there also says whether these branches can be automatically merged or not, right? I can say create the pull request here. If I want the auto-generated message to be used, this will be automatically doing it. If I want to put some comments of my own, I can say create a draft pull request also. And in this case, I'll not be actually asking for a formal review to anyone. Okay. So here for
Actually,
now, I just go ahead with this. Yeah.
yeah, where we can see the files we modified here.
That will be there in the branch. Right now, we are in the pull request view, right? So if I go to branches, we will be able to see the files. Okay, so let's say I go for code. And here we have the branches, right? So here I select the branch. Let's say feature improvement. And here I see the changes. Application 1, controllers. And this is the file. Okay. Got it?
Yes, yes. So actually, while creating the pull request itself, it will show the files which we
Yeah.
modified.
Yeah. Okay, so here I say create pull request. I can create the rules also before the merging, right? Continuous integration can be set up at a later stage once the CI pipeline I have configured. And here I'm able to see some details like whether there is a conflict or not, if multiple people have worked on the same set of code, right? All the conflicts will be displayed over here itself, where you can do the conflict management and take the decisions. And right now I am in a single user mode, so I cannot say that okay, the approval is required for someone or something like that. So here I say what kind of commit request or pull request I want to create. So by default, it is going for merge pull request, which means all commits from this branch will be added to the main branch via merge commit. Squash and merge. What is it? Simply one commit from this branch at a time will be added to the base branch. Rebase and merge means one commit from this branch will be recreated and added to the base branch. We go ahead with the default for now, merge pull request. And here we say confirm merge. So ideally what we should do before we come here and say merge is we should clone the project, or we should, if we don't have the rights to clone, probably we can fork the project on the local machine of the reviewer. And then within that, we can review the code and ultimately add the comments and all. And then we can actually come up over here and say merge. Okay, so here, let's say I go ahead with merge. Once the merge activity is done, automatically the pull request is closed also. And the changes have been merged. So there is no open pull request now. Changes have been merged into main itself. So now if I go to code, web, in the main branch itself, I go to web application 1, controllers, I should be able to see departments API controller directly. If merge is not done, in that case, the main branch will not have it. The new stuff, I mean, right? So once I'm done, let's say I don't want to have this branch anymore, I can go to that branch and I can get that branch deleted as well. This can be done from here, right? The delete option is there. I can go for the branches and then I can say delete, or else I can do it from here also in the Visual Studio, right? All options we do have here as well, push and all that. Manage branches is also there. So I can get some branch deleted from here also. Yes.
Yes.
Let's say I delete this. There is an option of restoring it. If by mistake someone has deleted it, we can restore it. There is a recycle bin kind of feature already available here. Right. And what is this? Your main branch is not protected. Right now it's open for changes from anyone. If I want this to be controlled, I mean the access to this to be controlled, I can say protect this branch, and I can say what all rules I want to create on this and what all actions I want to allow. Right? For this, I probably need to have a GitHub team or enterprise organization account so that multi-user licensing will be applicable. Got my point? So that user management can be done, and then what level of protection means permissions or authorization needs to be provided. For that, we do have the checkboxes here. Clear?
So here we cannot protect the branches.
We can protect the branches also. This is just like the main branch being protected, right? So if we have the sub branches also, those also can be protected. But for that,
No. I'm asking about this only. The protect this branch, main branch. So we can apply rules, right?
yes, yes. Right. So if you are in the team account or enterprise account, you will be having a multi-user setup, right? Where you can select which user is going to be allowed, which user is not going to be allowed. So selected users will be allowed, all others will be.
No, here we are having the require a pull request before merging. So all these checkbox can be ticked, and we can apply the.
Yes.
So I'm asking, can you scroll it down a little bit?
Yes.
Yeah, these things can be applied, right, to the main branch,
Yes.
right?
Yes.
So for this we don't require this GitHub Enterprise.
Correct. Correct. So these are permissions. User level permissions. If you want, then you need this.
Okay.
Understand?
Yeah.
Because right now it's a private repository. If it is a public repository, user level protection also will be there by default. You can then create the user based protection by selecting the global GitHub user accounts. Now, this branch or this repository being private, I am the only user configured for it. If I want my team members to be able to access this branch, most likely I need to have in fact, I need to have the GitHub team or enterprise organization account, right? Because it's a private one. If it is public one, then this option is not needed. I can just add any GitHub user, global GitHub user, I mean. Understood?
Yes.
Okay, so let's move on to the next level where we need to understand the next step, which will be the continuous integration and continuous delivery. Because as one of the step in this activity also, we just saw the same, right? Configure your CI/CD pipeline and so on. Let me close the unwanted things. And here I'll go to the whiteboard. So we spoke about two terms over here, CI and CD. What does CI stand for? What does CD stand for? CIS,
Continuous
Continuous
integration.
integration.
continuous integration. And what does this mean? Continuous integration. What is integration here? Integration of your code, right? With the production or staging. It could be testing also at times, depends on your workflow chosen. But the point is, whatever changes you are making, whatever PR request approvals you are receiving, based on that, the complete application with the new changes, suggested changes need to be compiled once again. Yes or no? So that the changes can be accommodated into the compiled product. Am I right? Code being changed means recompilation needed. Yes or no? This process is something what we call as build activity. Now, integration is not depending only on build. It requires build, running the test cases as well. And this combined activity is what we call as integration. Now, what is continuous integration? Anybody?
So whatever the small change that developer do that
Yes.
merge with the available for testing or review.
Yes. That could be production scenario also, right? We have
Yeah.
built the workflow like which does the integration within the testing environment into the staging environment. Then staging once receives the green signal goes to the production as well. Suppose we have defined that workflow already. Point is the first checkpoint will be continuous integration, which involves build and running the test cases upfront. Yes or no? Without which we cannot go even one step ahead. Correct?
Yes.
So the point is the changes keep on happening pretty rapidly these days with agile methodology. Agile methodology has made the development process quite quicker, quite faster. You target small things, whether it is feature improvement, whether it is bug fixing, whatever it is. Even we discuss the same thing for Git also. Yes or no? So as
Yes.
soon as that problem has been identified and worked upon, don't you think once the PR is also approved, the complete application build and integration along with running test cases should be completed instead of waiting for multiple changes coming in and then building it as a whole? Because the point is, if you build it as a whole, the users will be getting the updates in a delayed manner. Plus, at the same time, the build activity will take more time for accommodating large changes because usually the build tools work incrementally. Small changes also, if you're going with the build activity being triggered, probably only the changed component needs to be compiled once again and integrated with your already compiled code. Yes or no? Compilers have been optimized this way now. So we can leverage that facility. So build cycle will be reduced. Earlier, we used to have something like nightly builds and bi-weekly builds and weekly builds, monthly builds, something like that. That was just because the build activity used to take several hours. But with continuous integration, probably few minutes are enough because incremental builds are possible now. Correct or not?
Yes.
Yes.
Right? As an end user, what advantage do you get? Before going with that, let's understand what CD is. CD stands for continuous delivery. This is more
Delivery.
about deployment services, right? So you have built your code ready for deployment. And now that ready for deployment code you want to deploy to your target, which could be deployment server or which could be the actual client, depending on what kind of application it is. So usually for web applications, it is deployed to the web server. For mobile applications, you have a build or deployment server from where the or Play Store maybe from where the devices get the notification that this application has got an update. And which you have seen on Android and iOS phones, the updates are quite frequent, almost on daily basis, sometimes twice a day, you keep on getting the updates for some applications. Yes or no?
Yes.
How this has become so fast that daily or twice a day we are getting updates because of CI and CD. So the whole process is divided in two parts. Continuous integration is build and testing phase, and continuous delivery is packaging that for the deployment. Right? So at the end, what is the benefit? Quick delivery of your solution, your updates. Yes or no?
Yes.
Okay, so if I say what is the definition for continuous integration? What is it? It is basically a practice of frequently integrating the changes in the code from multiple contributors into a shared repository like Git. And then it involves the automation of the process of building and testing the software whenever the new changes are pushed to the version control system. Got my point?
Yes.
So once the PR is accepted, merge activity is done. After that, automatically the build activity should be triggered. Post which the test runner should run the test cases. And if all good, then it should move to the next phase, that is continuous delivery. How you define continuous delivery? It is actually an extension of CI only, right? Which targets the automation of the deployment of applications to different target environments, testing, staging, production. Whenever the code changes, pass the automated test, which is the last stage in continuous integration, right? Once the test cases are passed, automatically the packaging should be performed and the delivery should be ready. For web applications, directly web server gets updated version of your software. For desktop applications and for mobile applications, maybe some notifications are created from their respective servers, like Play Store or something. And then, depending on the configuration, the updates are performed. If it is set for automatic update, without notifying the user, it should be automatically updated or patched behind scenes. If it is set for manual updates, in that case, the notification should be there and the user should have the choice of whether to apply the update or go ahead with the older version. And you have seen that, right? You do have those settings in your phone also, whether it is Apple App Store or Google Play Store. Earlier, we used to have Windows Store also for Windows phones. Yes or no?
Yes.
Okay, now let's talk about the key aspects of both the processes. First, we'll talk about CI, that is continuous integration. What it involves. One of the key aspects is automated builds. That's what we discussed, right? Code changes automatically should trigger the build activity to ensure that the application can be successfully compiled, right? Once it is built, the next stage is automated testing, where after the successful completion of the build activity, the test runner should activate on their own and run all the tests, which includes unit test, integration test, UAT, etc., to verify the new changes are not introducing any kind of regression, means any breaking changes. adverse effect. I mean, understand?
Yes.
Next, this helps in early detection of issues. Because with small changes also, you are continuously building and testing the whole application along with the units. So you can catch any issue or conflict as early as possible in the entire development process, which ultimately helps you reduce the likelihood of integration problems. Understand?
Yes.
And then you have fast feedback. The developers get ready to receive the fast feedback on the quality of their code changes, which allows them to address the issues promptly, means as soon as possible. Yes?
Yes.
Say after integrating, there is a time gap of 1 month before you are notified that, okay, there is issue with your code. That's not very acceptable thing for a developer. First, why so long has been taken? That is the question. If it was bad, it was bad. It should have been notified me immediately when I submitted my work. Plus, if we keep this conflict part aside, the other thing is after 1 month, we may not remember what we actually did and why we did it. Because we might have moved on with some other task, some other code, some other module. So logically, our mind has been uh, diverted to something else. So recalling what we did and why we did will take some time. Yes or no? That's why the early and fast feedback is important. Clear?
Yes.
Let's talk about the key aspects of CD now. Continuous delivery. What it targets, the first thing is automated deployment. Automated deployment need not necessarily mean that you are actually changing the deployed code all the time. For mobile applications, that is not possible. It is deployed to your deployment server, Play Store or App Store or any equivalent. And from there, the application receives the notification. If it is manual update configured, the user has to accept the update and say, update my local installation. If it is automated update, application still receives the notification and gets itself updated behind scenes. Right?
Yes.
With this process, the downtime becomes zero, almost zero, if not zero. Your application need not be down anytime because most of the time the deployments are patch deployments or incremental deployments, which ensure that the users will not experience any disruption during the update process. Even if there is a disruption, it will be just for few seconds, right? And in most of the cases, users will not even realize that there was a downtime. Web applications, it's not possible to see the downtime. For locally installed mobile or desktop applications, we can feel that, okay, application is being updated. But again, if the automated updates have been configured, we actually need not get into that. Behind scenes, whenever the machine is running or device is running, the application will get updated without our knowledge. Yes or no?
Yes.
Saket, in some of the cases, they do this deployment in non-production hours.
Mhm.
So,
That
in
is
that
when
case,
there are major updates and which is going to take a lot of time. So there is a planned deployment in that case. Let's say 1 hour, 2 hours of uh, deployment process is there. So they pre-declare that okay, system will be down from from this time to this time. Understand? So that's for major thing. Like you are coming up with a major release, which is a complete replacement of the earlier version. Then maybe you need that process. Otherwise, if it is like patch deployment, then you need not do that because it will not take even few minutes. Most likely the updates will be taking few seconds only. So you will not have any downtime in that case. Sometimes the downtime is also because of the hardware replacement on the server side. Got my point?
yes,
Hardware replacement means your server itself will not be available. So definitely that will be causing the downtime. Okay. So in modern world, the downtime, major downtime comes when hardware replacement is or hardware upgradation is in place. At the application level, these days we don't have a long downtime as such. Got my point?
yes,
I mean, it's there, but it's rare. Okay. The next is rollbacks. Your continuous delivery system does provide a mechanism to roll back to previous version in case as a user you are facing the issue or you have detected an issue in the production. So you can say, okay, go back to previous version. Yes. I mean, whether it is like go back to previous version or whether it is like uninstall the last update, the terminology may be different based on the platforms where the application is running. But motive is the same thing, that I should be able to go back to the working version. Make sense? In some systems, you can roll back to any version of your choice. In some systems, you can just go back to the previous version. In some systems, you can go back to any of the three last versions, three recent versions. It depends how the configuration has been made. Am I right?
yes,
Next is environment parity. Continuous delivery does ensure that the production environment closely matches the development and the testing environments, which actually reduces the risk of deployment related issues. Right? So when I say that production environment closely matches the development and testing environment means what? The configuration and the system environment should match as far as it is possible with your development and testing environments. I mean, the operating system versions, the patches, the service packs must match so that deployment related issues arising out of this situation can be avoided. And this is further assisted by the use of the containerization technologies like Docker, Kubernetes, etc. because they allow you to copy or clone the entire environment. Yes or no?
Yes.
So these are the key aspects of continuous integration and continuous delivery. Let's talk about the benefits of using CI/CD. Some of the benefits you already know. With the discussions that we have had so far. The first one being from that list itself, faster development, and release cycles. I need not wait for a release for years or for months or for weeks. I can continuously keep on getting the new releases. Just for having one of the issue fixed. If I'm being made wait for few weeks or few months, it will not be acceptable. Right? As soon as it is fixed, even if there are more bugs, my bug is fixed. I should be having the solution which basically has got the solution for my problem. The other problems might be being worked upon at the same time based on the prioritization, right? And this is assisted by the automation of the many manual tasks which we used to do earlier, like build and uh, the packaging, right? Then, as a part of continuous integration, we said that the tests are automatically executed. Means one more benefit which arises out of it is higher code quality. This is entirely because of the test automation along with the continuous integration, which allows to catch the bugs and issues early, which result in improvised code quality. Right? Yes.
Yes.
Next is reduction of manual errors. This is purely because of more and more automation coming in. The best practices based automation policy can be created, tried and tested one basically, so that chances of human errors will automatically be removed. So that's why I said reduction. I didn't say removal, because if the policy, automation policy itself is incorrect, still there will be some manual errors, but over the time it will improvise, right? If we just depend on the manual approach, different people coming in the team might keep on making the same mistakes. Whereas if you have automation in place, which is tried and tested one over the years, even new people coming into the team will not hamper it because the policy is already in place. Their code will be accepted if and only if they are following the standards. Yes or no? This will not be on
Yes.
day one. The most effective reduction will be achieved over the years or over the time. Your policy will keep on improvising, right? Next is improved collab. We already discussed this. CI/CD encourages the collaboration among the developers, testers, operations team, even the end user team also, which ultimately is driven by the better communication and understanding, right? This also allows faster issue resolution. You can map your ticketing systems also so that any issue raised within the ticket can then be picked up by some developer and can be worked upon, and the fixed code can then be just going through the entire process of commit, then pull request, and then merge, and then continuous integration, which runs the test cases and then goes to the continuous delivery so that the user gets the resolution as soon as possible. Yes.
Yes.
Next is increased confidence. With automated testing and the deployment processes, teams will have more confidence in their ability to release more reliable software, and that too pretty sooner. Yes or no?
Yes.
Next one, scalability. The CI/CD pipelines can easily scale to handle more complex or less complex projects, larger or smaller development teams as per the need, with minimum efforts. Got my point? Basically, the CI/CD platforms are built like that. That the project size, complexity of the project, the team size, composition of team should not have any effect on CI/CD. So by default, they are scalable. Understood?
Yes.
Then next is consistency. CI/CD ensures the consistent development, testing, and deployment processes across different environments, so that there will be no question of like, okay, it's working in development environment but failing in testing, or it is working in development and testing but failing in the production scenario, right? Because you will be having the same configuration all through. Got my point? Next is risk reduction. This you can understand. With all the other points, by default, we know that the small releases will reduce the risk associated with huge, infrequent deployments. Right? And then one more point we already discussed earlier, that we have an enhanced feedback loop. Developers basically receive the feedback as quickly as possible with respect to the code changes they are making, which enables them to iterate and improve more quickly, more rapidly. Yes.
Yes.
Okay, so we'll get the session finished here itself. In the next session, we'll build upon this, where first of all, we'll be understanding the stages of a CI/CD pipeline, followed by the practical implementation, and how Git can help us with CI/CD. Right? So practically we'll be targeting GitHub Actions over there. Okay. And if time permits, we'll be talking about the best practices to be followed for Git-based CI/CD with GitHub Actions. Okay.
Yes.
So that is it
Okay.
for today. See you tomorrow, 9:30 a.m.
Okay.
Thank you, team.
Thank you.
Thanks, bye.
Just one question here, like if you're able to access Git now.
Yes, okay. Actually, we have to raise a ticket. So if managers approve, so based on that, we are
So
getting access.
anybody got the access? Why I'm asking is because that practical assignment I need to evaluate now. And right now with the current situation, it seems like the Git is the only option, right? But for that, you need to have the approval. So just follow up with your managers also if they have not approved it yet. Okay.
Okay.
Thanks. See you tomorrow.
Yeah, sure.
Thank you.